In this video, let's show you the basic 3D plotting techniques in Matplotlib to amplify your data analysis skills. Let's get into it. Okay, then we start by importing Matplotlib, PLT, like that, and then I'm also going to import MPL toolkits. You don't have to install this manually, it will already come installed as you install Matplotlib. I'm just going to type in MPL toolkits, and then we import mplot3d, like that, and then I will also need numpy, SNP, like that. Now I'm just going to copy the dataset, and you can have your own dataset in here. I'm just going to show you all of the different plots that you can do with this dataset. Paste this here. Okay, so here we have the year, the sea level, and the temperature, basically indicating as the years went on, the sea level has been increasing steadily, and so is the temperature. This is a major concern, and it should be addressed. So we're doing this by the 3D visualization and then acquiring some knowledgeable insights. That's kind of the idea. So first, let's create a 3D scatter plot. And then the way you first do this is first by mentioning the fig size, plc.figure, mention the fig size. For my case will be 8,6, like that. And then now you should create a variable or a plot variable through which you can plot all of your 3D plots. I'm just going to call this AX and then type in fig.add subplot. And then since this is 3 dimension, you have to mention 3 values. Where do you want to keep this subplot? I'm just going to type in 1, 1, 1. You just have to type in 1, 1, 1. And then the most important thing here is to mention the projection, which will be 3D, like that. And then now you can type in ax.scatter, mention x, y, and z, which will be our year, comma the sea level, comma the temperature, like that. I'm also going to mention the color, which will be, let's keep it blue for now. Then let's mention the marker as well. We want it to be the O marker. Now it's time for us to set the labels. So ax.set_label, x label will be year. Similarly for the y label, sea level in limiter. And then our z label will be temperature in Celsius. Now we can also set the title for this plot, set_title, which will be 3D scatter plot, like that. Now just type in plt.show and then run this code. And here we see we get a scatter plot in the shape of 3D, and you can also rotate this and see how the plots are working in this case. Now here we see a steady increase in the sea level as well as in the temperature as the years progress. Now we can also do this in terms of line plot, which is what I'm going to do next. Now in order to do the line plot, what we have to do is just change this to first, rather than scatter, just type in plot. You mention the year, sea level, comma the temperature. Now again you mention the color, which will be blue. Now this time you also have to mention the line width, and this should be 2. Now again the marker, which is going to keep it as this, like that, and then change this to line plot. Just type in plt.legend to see how that works, and run this code. And there you go, you see a line plot over here. Here all of the points are connected, and now we see the steady increase more clearly. As the years increase, the sea level seems to be increasing, and so is the temperature. You can just rotate this around to confirm. Like right around, as you see here, the years are increasing, and we see that the temperature is constantly increasing. And so as you rotate it downwards, you will see that as the years increase, the sea levels also increase. Very nice. So next, I'm going to show you how to do a surface plot. Okay, so in order to create a surface plot, the first thing that we have to do is convert all of these to numpy arrays. So let me just do that. np.array, like that. And then now I'm going to show you one very important function when it comes to doing surface plots, and it's called the mesh grid function. So basically, let me just create x variable and a y variable, and then assign that as, let's just type in np.meshgrid, pass in the 2 parameters, that is our year and then our sea level variable, like that. These 2 are numpy arrays. So what this mesh grid will do is it will convert this into a 2-dimensional array, and this as well, such that both of these shapes are just the same, such that the year shape is also equal to the sea level shape, and then that is assigned to x and then y. So let me just print that and show you. First, let's comment this out, and then type in print x.shape, comma y.shape. Let's just run this. Oops, we also forgot to put this with the parentheses. Let's just do that. Just close this over here as well, like that. Now let's just run this. and we see that we get 15, 15 and 50, 15 as x and y. Let me just print x itself and then show you how it is. So we have the initial values for x and y, that is the year column will have all of the values in terms of x, and then C level will be the values for y. So let me just run this, but then show you what is the difference when you use the mesh grid function. And we see that this is the difference. So here we see 15 times this 185 is repeated so that we can get the exact shape that is matched with x as well as y. So hopefully that made sense. So what we're going to do now is use the surface plot function to get the surface plot, and also make sure that z is in 2 dimension as well. So what I will do is just type in z equal to temperature dot reshape the x shape itself, because that is going to give us a better plot. And then instead of using here as plot, I'm just going to convert this to plot surface like that. Change this to x, y, and z, x, y, z. And then instead of typing in C, we're going to type in C map. Again, this only refers to the color, but then here we have a different range of colors. I'm just going to use plasma. There are just many different colors like viridis. You can just research on that. Remove all of this like that, and change this to surface plot. We don't need legend anymore. Let me just run this and show you. Let me just try to put this in NumPy array format. Actually, let's just try putting this in -1 fashion. And there you go. Now we see the surface plot itself. This is in the plasma color, and we get a very straight line surface plot. We're seeing this because we converted the year and then the sea level inside of the same array, whereas we left the temperature in 15,1 fashion itself. So you can just play with this and then get the right surface plot that you wish to have. And now I'm going to show you the final one, which is bar plotting. And to show you bar plotting, I'm not actually going to use the same data set. Instead, what we will do is we will create a random set of numbers and then try to put a bar plot, because it is kind of complex, so it's always good to show the initial and the basics first. Let me just clear all of this. First, what I'm going to do is create a number of bars. How many bars do we need? I'll just have it 10 for now, and then generate random 20 numbers for x, y, and z, maybe 10 numbers, and paste it over here. These are the z coordinates indicates the height of the bar. So what I will do, I will also type in the width of the bar to be maybe 5. And then now what I will do is create the 3D bar plot itself. So again, we just type in fig is equal to plt.figure. Fig size will be 8, 6. Now again, create AX variable. Actually, I'm just going to copy that and paste it over here because I already showed you that. And then now, I'm just going to type in ax.bar3d. This is the function used to create bar plots. Now here, we first mention x, and then y, and then for the z, we just type in np.zeros and then you pass in z. So why are we doing this? So this will indicate the point where we want to draw our bars. For example, x, y, 0. We are generating 10 zeros and then aligning that to x and y, because this is the point where we want our bar plots to be. So essentially, the first point is going to be x1, y1, 0, x2, y2, 0, and it keeps going on and on. Now in that specific place, we want to position our bar plot. We want to position our bars, and the bar width should be our width itself in terms of x coordinate, and similarly in terms of y coordinate, we again want the bar width to be the same, whereas in terms of the z coordinate, you just type in z, because that is essentially the height of the bar. That is how big we want our bars to be in that specific position. So when you actually look at the output, you would understand this much more. Again, let's just set up all of the titles and then type in plt.show and then run this code. Here we see that we get different bar plots at different places at random generated numbers, and I kind of see that the width is a bit big. So I'm just going to change this to 3 and then see if that's working. And let's just run this code. And yep, now we're able to see the bar plots much better. Now we're seeing different bars because we're generating random numbers each and every time running this code. So when we run this once again, we will see a different set of bar plots, just like this one. And then let's just try that for one more time, and like that. So this is how you can do bar plot in 3D format.